Jaguar Cars Incorporated presents Performance, the Jaguar Heritage, Part 2. The performance-conscious Jaguar owner takes great pride in the ability of his car to deliver a high level of performance without sacrifices in ride, luxury, or convenience. The Jaguar technician plays the key role in maintaining this high level of excellence Jaguar owners expect. His understanding of the powertrain and systems, combined with an ability to accurately diagnose problems, will ensure that performance remains a Jaguar hallmark throughout the life of the vehicle. Part 1 of the Performance series provided descriptions of the powertrain and associated systems. This information should be thoroughly understood before viewing Part 2. Part 2 of the Performance series will concentrate on testing and evaluation of performance-related problems. We'll begin testing and evaluation by reviewing the verification process. Before making a road test to evaluate a complaint, preliminary checks should be carried out. Check all fluid levels and inspect for possible leaks. Top up as necessary with the specified fluid. Inspect all fuel, vacuum, hydraulic, and coolant hoses, clamps, and fittings. Check visible wiring and connections for security, chafing, and good contact. And inspect the road wheels and tires. Be sure they are in good condition, meet factory specification, and are inflated to the correct pressures. When evaluating performance, it is necessary to be familiar with the vehicle and know what level of performance to expect. Keep in mind that acceleration performance is open to a wide range of interpretation by individual customers. Be aware of the effect that accessory operation has on performance. The air conditioning compressor, alternator, and engine fan all require horsepower to operate. As much as possible, try to duplicate the weather, temperature, and road conditions under which the complaint arose. Also, duplicate the vehicle condition. Vehicle loading, cold or normal engine temperature operation, and accessory load all have a considerable effect on performance. Begin the operational test by checking the effect of related systems on the engine operation at idle. Turn the steering wheel through the full range of travel to check the condition of the power steering pump and steering gear. Apply the brakes to check if a vacuum leak exists in the brake vacuum circuit. This will be evidenced by a change in engine idle speed. The climate control system can be checked for vacuum leaks which affect engine performance by operating the system in all modes, and by cycling the temperature selector to operate the water valve. Remember that individual color-coded vacuum circuits exist within the climate control system. When driving, several observations should be made before checking performance. Be certain the transmission shifts automatically from first to second to third, and downshifts from third to second to first. Check the effect of the vacuum-actuated cruise control system on engine operation. Any change could indicate a vacuum leak. When testing XJS models, keep in mind that engine vacuum is also used to actuate the transmission modulator. Conduct a transmission stall test to determine the condition of the torque converter and transmission. To evaluate accurately, compare the results you obtain with the specifications shown on the reference card. Perform the stall test in a cleared area with both foot and hand brakes applied. Do not stall for more than 10 seconds at a time, and allow ample time between tests for the transmission to cool. Performance road tests should always be conducted in conformance with the legal highway limits while observing all safe driving practices. If the fault area causing the performance problem does not become apparent during the complaint verification process, further testing is required. Suspected vacuum leaks can be confirmed by clamping off individual supply hoses while the engine is idling and the vacuum-actuated system is in operation. For example, a suspected cruise control vacuum leak should first be checked by clamping off the supply hose. If a change in engine speed is observed, a vacuum leak is indicated. When a performance complaint is received, there is a tendency to immediately suspect the fuel injection system, but the EFI system is only one of many systems affecting performance. A useful tool which can aid in performance diagnosis is the Kent-Moore Pulse Duration Tester. Pulse duration is the time, in milliseconds, that the fuel injectors remain open. The tester cannot verify that the correct amount of fuel is being injected, only that the injectors are receiving the correct timed pulse. Due to differences in their EFI systems, connection to the XJ6 and XJS varies. In the XJ6L system, all 6 injectors pulse together. Therefore, connection to any injector will give the reading for all injectors. The operation of the P system in the XJS requires connection at the ECU. Carefully disassemble the connector cover to gain access to the individual pins. The injectors in the XJS are pulsed in 2 groups of 6. Either pin 11 or 12 can be used to read one group, while either pin 29 or 30 can be used to read the other group. Here we'll show the sequence of pulse duration readings you can expect to get as a cold engine at 60 degrees Fahrenheit is started and warms to normal operating temperature. These apply to both the XJ6 and S. The XJS will require 2 observations, one for each injector group, to obtain complete information. As the engine cranks for starting, an initial pulse duration of approximately 6.4 milliseconds occurs until the engine starts. This will confirm that cranking enrichment pulsing is being provided. At startup, the pulse duration drops off to approximately 4.5 milliseconds, indicating cold engine enrichment pulsing. About 1 minute after startup, the pulse duration drops further to approximately 3.8 milliseconds, confirming that the fuel-air mixture pulsing is being reduced by sensor inputs to the ECU. When normal operating temperature is reached, a pulse duration of approximately 2.5 to 2.7 will be shown at idle with no engine load. This indicates that the normal hot idle pulsing is being delivered. If drive is selected at idle, placing a small load on the engine, the pulse duration will increase to approximately 3 to 3.1, confirming that the load has been sensed. Note that the pulse duration at idle will be affected by the CO at idle setting, which is read with a CO meter on the XJ6 and the feedback monitor on the XJS. One additional observation which will prove useful is the pulse duration at stall speed. After a 3-second initial surge, the pulse duration will drop off to approximately 8.8, indicating full load pulsing. This quick and simple sequence of checks can verify correct EFI operation up to the point of actual fuel injection. Injection quantity at idle can be confirmed by combining the use of a CO meter on the XJ6 or the feedback monitor on the XJS. The feedback monitor high numbers indicate a lean mixture. If the specification is observed at hot idle along with the approximate pulse duration, the system is performing correctly at idle. However, a lean mixture indicates that the possibility of clogged injectors or low fuel pressure exists. Fuel pressure testing and injector flow testing will positively determine the need for injector cleaning. The pulse duration counter is a diagnostic aid only. Any EFI component failure must be confirmed by conducting the appropriate EPI-test sequence. While on the subject of the fuel system, the operation of the XJ6 fuel changeover valves can easily be checked. With the ignition on, select the left fuel tank. Then, jump the fuel pump contacts, numbers 36 and 39, at the airflow meter connector to activate the pump. In the trunk, momentarily clamp off the left fuel feed line. The pump should become noisy, indicating no fuel flow. Immediately release the clamp. Next, open the left filler cap and depress the flap so that the fuel return can be observed. A look into the right tank should show no return. Select the right tank and repeat the process for that side. The constant energy ignition systems used in both vehicles are checked by conventional means. Correct timing should be confirmed first. Then a thorough analysis of the ignition system condition should be made. The test equipment manufacturer's instructions must be carefully followed to ensure accurate results. In addition to oscilloscope equipment, the Lucas Ignition Analyzer is a useful tool for checking the low-tension circuit. As described in Part 1, the ignition vacuum circuit employs a vacuum regulator in both the XJ6 and XJS. Operation of the regulator can be observed by teeing in 2 vacuum gauges and running the engine through a speed range. The reference card chart shows the correct operating range for each car. Emissions systems for air injection, canister purging, and crankcase breathing have overlapping control. These should be operationally checked from cold start through complete warm-up. The emissions system operational summary, shown on the reference card, indicates which subsystems are in operation during the various phases. XJ6 air injection and canister purging should be checked during warm-up and at normal temperature. XJS ignition advance, canister purging, air injection, and supplementary air circuits should be checked during the first 45 seconds of operation, warm-up, and at normal temperature. Control of engine blow-by emissions depends on tight sealing of the crankcase. If high exhaust HC readings are observed during testing, consider crankcase sealing as a potential source of the problem. Correct fitting of the oil filler cap and the dipstick seal are often overlooked. If fitted incorrectly, they will allow leakage into the crankcase, which greatly increases exhaust HC level. Oil dilution is another possible source of high HC levels, as excessive blow-by or vapors occur from the thinned oil. The exhaust system is an area which should never be overlooked when considering performance. Damage or restriction in the system reduces efficient exhaust gas flow and prevents the engine from developing its full power. A catalytic converter could become blocked and overheat. On XJS models, this will be indicated by a change in color of the paint marking. The engine mechanical condition, obviously, greatly affects performance. Cylinder balance, which dynamically measures each cylinder's performance, should be checked while making the scope analysis. Compression pressures can also be checked and compared to the specifications shown on the reference card. A maximum of 10% deviation should exist between cylinders. High exhaust HC content can indicate leakage past the piston rings, valve guides, and seals. The efficient transmission of engine power to the road surface is influenced by the drivetrain condition. The stall test evaluated the torque converter and transmission condition. However, the drive shaft and rear axle condition can also affect performance. And do not overlook brake operation when evaluating performance. Brake calipers which do not release properly will rob a great deal of engine power. The information provided in this second part of the performance series will assist the Jaguar technician in testing and evaluating performance-related problems. The next in the series will deal with basic settings and adjustments which apply to performance. This completes Performance, the Jaguar Heritage Part 2, another Performance Masters service training program.